Hello my dear students, I welcome you all for the chemistry class. So in the last video we discussed about redox reactions, that is oxidation and reductions. Also how to calculate the oxidation number using the oxidation number rules. So we studied around 7 rules about how to assign oxidation numbers. Okay. So today we are going to see redox reactions in terms of oxidation numbers. Also types of redox reactions. Okay. So before going to discuss about the types of redox reactions, so I will recall how to calculate the oxidation number for the given element. See now, example, calculate the oxidation number for the underlined element. Okay. See, now that compound is CH2F2, that underlying element is carbon. So calculate the oxidation number for carbon. See, now go through the rules. So keep the compound oxidation, the total oxidation number for the given compound is 0. Now calculate the underlined elements oxidation number. For that you can keep either X or you can write the element symbol as it is. So I am writing here how many carbon atoms are here, only one carbon atom plus hydrogen 2 into hydrogen plus 2 into fluorine equal to 0. So one carbon plus for hydrogen atom, see in the oxidation number in the rules, if hydrogen is combined with non-metals, see carbon is non-metal, fluorine is non-metal, so the oxidation number is plus 1. So write plus 1 plus fluorine always gets minus 1 equal to 0. So carbon, write 1 carbon, I am writing here carbon plus 2 into plus 1 plus 2, and here it is minus 2. Sorry, one mistake is there. It's not a mistake, it's the correct only. So 2 into plus 1, that is plus 2. Then here 2 into minus 2, that is minus 2 equal to 0. So carbon plus 2 plus minus 2 is 0 equal to 0. So carbon is, the oxidation number of carbon is 0 only. Okay. So in the compound CH2F2, that oxidation number of carbon is 0. Clear? So this already we discussed in the previous class. I will give one more example. Now KMnO4 potassium, this is called potassium permanganate. Calculate the oxidation number of manganese. Mn means manganese. So keep the compound oxidation number is 0. Potassium, that is it is in the first group, so always plus 1. So K plus Mn plus 4 into oxygen equal to 0. So potassium always plus 1 plus manganese you are going to calculate. So keep manganese as it is plus 4 into oxygen, that is minus 2 equal to 0. So plus 1 plus manganese minus 8 equal to 0. So Mn minus 7 equal to 0. So manganese equal to plus 7. Here the symbol plus and minus is very important in the oxidation number. Clear? So this is the way you can calculate the oxidation number for the given element. Clear? Now redox reactions Redox reactions in terms of oxidation numbers. Oxidation numbers. See, during redox reactions, what is redox reactions? Redox means, so in a reaction, if oxidation plus reduction takes place simultaneously, that is called redox reactions. Okay, so both oxidation and reduction takes place, that is called redox reactions. So during the redox reactions, the oxidation number of element changes. Okay, a reaction, so we are writing the definition. So a reaction in which oxidation number of the element increases is called oxidation. Okay, so a reaction in which oxidation number of the element increases is called oxidation. Okay, also a reaction in which the oxidation number of the element decreases is called reduction. Sorry. Clear? So, if the oxidation number increases, that is called oxidation. If the oxidation number decreases, that is called reduction. That is the concept. So, redox reaction in terms of oxidation number. If the question comes, this is the meaning. A reaction in which oxidation number of the element increases, that is oxidation. A reaction in which oxidation number of the element decreases, that is called reduction. Clear? So, we will see the examples. So, before seeing the examples, we will see the types of redox reactions. So, types of redox reactions. First one is combination reaction. Number 2 is decomposition reaction. Decomposition reaction. There are 5 types are there. Third one is displacement reaction. In displacement reaction, there are 2 more types. One is metal displacement reaction. Metal displacement reaction. Another one is non-metal displacement reaction. Okay. So total 5 reactions. First one is combination reactions. Second one is decomposition reaction. Third one is displacement reaction. In displacement reaction, there are 2 types. One is metal displacement reaction. Another one is non-metal displacement reaction. Fourth one is disproportionation reaction. Disproportionation reaction, or we can say auto redox reactions. Then fifth one is competitive electron transfer reaction. Electron transfer reaction. Clear? So there are 5 types. One is combination, second one is decomposition, third one is displacement reaction. In displacement reaction there are 2 types. One is metal displacement, another one is non-metal displacement. Fourth one is disproportionation reaction, that is called auto redox reactions. Then the last, that is fifth one, is competitive electron transfer reactions. Clear? See, the first one we will see one by one. The first reaction is combination reaction. First one is combination reaction. First type is combination. Combination means combining of two elements. Combining of two elements. So redox reaction in which two substances. So redox reactions in which two substances combine to form single substance, a single compound. You can say single compound. Okay, and it is called combination reactions. So in the redox reaction there will be two substances combined together to form a single compound. Okay, example, when carbon plus oxygen, when it combines together it is getting carbon dioxide. Okay, carbon and oxygen, it is giving carbon dioxide. Now you see that now assign the oxidation number for all the elements. For carbon, carbon oxidation number is always 0, oxygen also always 0. Then here find out the oxidation, because for oxygen we know the oxidation number, that is -2. So carbon, find out the oxidation number of carbon. Carbon plus 2 into oxygen equal to 0. So carbon plus 2 into -2 equal to 0. So carbon will come plus 4. Carbon, the oxidation number of carbon is plus 4. Okay. So now this is plus 4 and this is plus 2. Oxygen is -2. So plus 4, this is -2. See, always write the oxidation number for single element. See, here there are 2 oxygen atoms are there. So use for single element. Okay. So now find out the decrease and increase of the oxidation number. Okay. So carbon, here it is 0 and here you see it is 4, plus 4. So oxidation number is increased from 0 to plus 4. So it is called oxidation. Clear? Oxidation. Now you see, for oxygen, here it is 0 and you see here there is -2. So oxidation number decreases. So it is reduction. Clear? See, carbon increased 0 to plus 4. So oxidation number increases. So carbon is oxidized. Clear? Now see, oxygen, it is decreased from 0 to -2. So oxidation number decreased. So it is reduced. Clear? Understand? See here, carbon, the oxidation number is increased from 0 to +4, and oxygen, the oxidation number is decreased. So it is called reduction. So oxygen is reduced, carbon is oxidized. That is the meaning. Do you understand now? I think you understood. So here oxidation and reduction takes place. So it is called redox reactions, and the type of redox reaction is combination reaction. In combination reaction, what is happening? Two single substances combining to form a single compound. Okay, and you check which is oxidized and which is reduced. Whenever you write the oxidation number, find out and calculate the single atoms. So oxidation number for single atom. Okay, so here actually oxygen, the total oxidation number of oxygen is -4, but there are 2 oxygen atoms, so write for only 1 oxygen atom. Okay, so here oxygen is in molecule state, it is, so it is 0. Carbon is single, so it is 0. So now check the rules, you can understand how to assign the oxidation number. Clear? Now we will see the second type, decomposition reaction. Second one is decomposition reaction. Okay, what is the meaning of decompositions? Decomposition means breaking of a compound. So breaking. Example is potassium chlorate KClO3. It is decomposed by heating into potassium chloride plus oxygen. Okay, here now you have to balance the equation. Here 3 oxygen atoms are here, so I am adding here 3 I am adding, here I am putting 2, so 6 oxygen atoms is balanced. Now remaining potassium and chlorine, so put 2 here. Now this equation is balanced. Okay, so what is the meaning of decomposition reaction? A redox reactions in which compound breaks down into 2 or more compound are called decomposition reactions. So compound breaks down into 2 or more than 2 compounds, or 2 or more compounds are called decomposition reactions. Okay, now this decomposition reaction is just opposite of this combination reaction. Now assign oxidation number for this potassium chlorate and also for the products. Now check which is reduced and which is oxidized. Okay, now calculate the oxidation number for chlorine. So in potassium chlorate, KClO3 gives KCl plus 3O2. So balance the equation, here put 2, here 2. Okay, now here there are 2 potassium atom, then 2 chlorine atom plus 6 oxygen. This 2 means common for all, so 6 oxygen atoms. Okay, now 2 potassium atom, that oxidation number for potassium is +1 always, plus you are going to calculate the chlorine atom, keep 0, plus 6 into -2 equal to 0. So 2 plus 2Cl minus 12 equal to 0. So 2Cl minus 10 equal to 0. Cl equal plus 10 by 2 will get plus 5. Clear? Same way, here 2 KCl is here 0. You know that potassium always plus 1, so 2 into plus 1 Cl, you are going to calculate 2Cl equal to 0. So plus 2 plus 2Cl equal to 0, 2Cl equal to minus 2, Cl equal to minus 2 by 2 equal to minus 1. Clear? Now assign oxidation number. So potassium already we calculated. So chlorine, that oxidation number is plus 5. Okay. Here that oxidation number is minus 1. Here oxygen always 0. Potassium is plus 1. Oxygen, for single oxygen, minus 2. So don't forget, always calculate the oxidation number for single atom. If it is 3, 5, 2, it's not a matter. If there are 5 atoms, you have to calculate only for single atom. So oxygen always minus 2, potassium plus 1, chlorine is plus 1. Sorry, chlorine is always minus 1, but here in this compound, chlorine oxidation number is plus 5. Clear? Now check which is oxidized and which is reduced. Now plus 5 to minus 1, that is oxidation number decreased, so it is reduction. Now minus 2 to 0, here it is oxidized. Clear? So chlorine oxidation number, that is decreased, so that is reduction. How much decrease? It is from plus 5 to minus 1, so it is reduction. Now oxygen, that is oxidation number increased, so it is oxidation. How much it is increased? It is increased from minus 2 to 0. Clear? So this reaction is called redox reaction. Why? Oxidation and reduction takes place. Okay. So what type of redox reaction? This is decomposition redox reaction, because one reactant and 2 products. Clear? So you have to calculate the oxidation number for one element and check whether it is increased or decreased. If it is increased, oxidation number is increased, that is oxidized. If oxidation number decreased, that is reduced. Okay. So this is the second type of redox reactions. Clear? Now third one. Third reaction is displacement reaction. It is also redox reactions, because we are seeing the types of redox reactions. Displacement, it means it has to displace something from one place to another place, that is displacement. So redox reactions in which ion or atom, in which an ion or an atom in a compound is replaced by an ion or atom of another element are called displacement redox reactions. displacement reactions. Okay, so it is again further classified into metal displacement, another one is non-metal displacement. Okay, so first we will see metal displacement reactions. So first one is metal displacement. Okay, see this metal displacement you can explain by one small experiment. So place a metal strip, that metal strip is zinc. So keep zinc metal in a copper sulfate solution, that is aqueous copper sulfate. Aqueous copper sulfate always the color is blue color. Okay, the color of copper sulfate is blue. So this is aqueous copper sulfate. Aqueous means that salt is dissolved in water, that is called aqueous copper sulfate. And this metal is zinc. Then observe the solution. After some times the intensity of the blue color will disappear. It will slowly reduce and finally disappear. Okay, see here. And finally this zinc, you can, before seeing this zinc it will looks white color. Then after some time what will happen, here the blue color is slowly disappear. Then later what happen, the zinc it will be coated with copper. Okay, right. So place a zinc metal in the copper sulfate solution. Then after some time observe the solution, it will slowly reduce it to that intensity of the blue color will be reduced and finally disappear. Okay, so you can see that copper it is coated on the zinc metal. So this is called a displacement metal, that is metal displacement reactions. See the equation. Now see the equation, that is copper sulfate CuSO4, it is in aqueous, plus zinc it is solid, that is metal. So after the reaction what will happen, copper it will become solid plus zinc sulfate ZnSO4, this is aqueous. Now identify that redox reactions, which is oxidized and which is reduced. Here copper is 0. See how copper is always 0 because it is metal. Then zinc it will come plus 2, you can calculate. Here copper is plus 2, zinc is 0. Now check which is oxidized and which is reduced. See, this is reduced. So this is reduction. Copper is reduced, zinc is oxidized. So oxidation. Why? Because oxidation number from plus 2 to 0 it is decreased. Then here it is increased, 0 to plus 2 it is increased. So it is copper is reduced, zinc is oxidized. Clear? You can check. Okay. Next one is non-metal displacement. Number 2, that is non-metal displacement. See the example. Zinc plus HCl, you will get zinc chloride ZnCl2 plus hydrogen. Balance the equation, put 2 here. Then that's all. This equation is balanced. Now assign oxidation number. This is 0. Here hydrogen is always plus 1. Here it is 0. So it will come here plus 2. Okay. So which is oxidized and reduced? Zinc is oxidized and hydrogen is reduced. This is non-metal displacement. See here, hydrogen, this chlorine you see here, chlorine is displaced. Okay, so it is attached with zinc, so it is zinc chloride. So chlorine is displaced from HCl. Okay, so here it is oxidized and it is reduced. Why? Because oxidation number decreased, here oxidation number increased. Clear? So today we will wind up. Then in the next video we will discuss about the remaining types, that is disproportionation reaction and competitive electron transfer reactions. So 2 more types are remaining. We will complete in the next video. Okay students, so thank you very much.